All right, let's get started. Thanks everyone for joining. Today we're going to talk about monitoring the data lake, detecting data anomalies in ETL pipelines. My name is Paul Lapis. I'm the co-founder of Intermix.io. Intermix is a single dashboard that helps data teams keep an eye on mission-critical data flows. These are the content in this presentation are lessons that we have learned from running a massive data pipeline and data analytics infrastructure. Our system is Redshift based. It processes over 100 billion events a day, and it uses Redshift, RDS, Elasticsearch, Lambda, Kinesis, and S3 is our primary data lake store. Prior to Intermix, I had built the infrastructure and platform at Intelligent, which was a performance monitoring for mobile. Now, you're probably here at this webinar because you're working at a company that is leveraging data to innovate and to win in the marketplace. And in fact, the best companies in the world realize that data is a key differentiator, and their ability to grow and add value to their companies in the next 20 years is going to be a function of how good a job they are at leveraging insights from their data. And the reason why we're seeing this happen now is because of the economics of the cloud makes it easy for companies of all sizes to store all their data forever and to process it very cheaply. Machine learning libraries are no longer secret sauce. They're open source, TensorFlow, et cetera. Even though the algorithms are 60 years old, the big tech companies have now open sourced these libraries and they're accessible by any company. And then finally, data teams have become a strategic asset. So organizations are hiring data scientists, data engineers to come together to get more insights out of their data. And this causes new problems. A company will typically hire data scientists first with a charter to, get insights from data to help the company. However, data scientists, they require, they're going to run algorithms on top of all your data, and what they need is access to all data. We need to be able to query it very quickly, and it has to be in a unified format, in a common format, so that their tools work. The data has to be clean, correct, and complete. And so the task of organizing the data in a way where it can be available to the analysts and data scientist teams typically falls onto the data engineer. This is, a lot of the people that we work with at Intermix are data engineers. And what they will do is build data pipelines. Data pipelines are engines or ways that you can acquire, process data at large scale. It's pretty easy for people in the company to think that it's pretty easy to do that. But it turns out it's supremely hard to be able to acquire data, build data pipelines, and make sure that they're correct. And so the key to success here is in making sure that the data is valid. Data analysts, data scientists, and analytical applications need to be confident that the data makes sense. And your challenge is to constantly evolve these pipelines. You get new data sources, new queries, new people, new projects are added to the teams. And so your ability to be successful is really a function of that. And so you've got multiple databases in your environment, and you're typically using an orchestration, and you would be using an orchestration system like Apache Airflow to coordinate how data flows through multiple systems. And so, your end goal, right? What if you had confidence that your data pipelines were working as expected? That as you introduce new changes to your ETL processes, new queries, modified existing queries, brought in new data sources, that existing data wasn't impacted, and the new data that you were adding to your system was correct and validated, and that ultimately, when there are issues, unexpected issues or other issues, that you're the first to know, that you're not waiting for your customers, for people internal to the company or analysts or data scientists, that they're not telling you that they're sort of are worried about the quality of the data, or the data is not available, or the queries are slow, but you're the first to know of problems. And it turns out this is quite hard. It's hard because data as organizations are evolving to get more out of data, data is being seen more as a service. Whereas in the past, only a small number of people had access to the data infrastructure. Now it's open up to the whole company. And in fact, data analysts, data scientists, and data engineers expect that they can write new workflows to run against this data infrastructure, and you're not always in the loop. So new data sources are being brought in, and you're kind of the last to know sometimes when that happens. Third-party ETL services means that queries are being run on your system that written by developers that you've never talked to, and so those services can do unexpected things that you need to be aware of, for in order to properly monitor and maintain your system. And it's really hard as you have multiple databases and data flows span multiple systems. Detecting issues across thousands of tables, millions of queries in real time is impossible to do without some level of automation. And so we've seen this problem within our customer organizations and also within ours. We've seen a few ways that companies approach it. Probably the primary way is a do nothing approach. It's hard enough to build this stuff in the first place, that oftentimes thinking about data quality and validation as an afterthought. So you just let your users do QA for you. This is the most dangerous approach, and I don't think anyone will disagree that it's the worst approach, not ideal. Some folks will start adding tests to their ETL jobs either at the end of an ETL job or as part of their DAGs or tasks. They'll start writing, sort of adding some tests there. That's a great start. Some issues with that approach is, what if your ETL goes down? That actually causes issues, and you want to separate concerns. You want to separate your monitoring from your pipeline infrastructure so that those two things can fail separately and one won't impact the other. Also, that particular ETL job or task won't be able to see end-to-end your entire data flow. And so it won't always have the context that it needs to properly do the validation that you need. And then, for example, you oftentimes will need access to historical data to do comparisons or to classify behavior, and your ETL job doesn't have any access to historical data easily. Or you start writing scripts. You start writing your own scripts, and that's really hard. It's hard to maintain them, to extend them. It's hard to validate that the scripts are working as expected. So you end up spending a lot of time doing that. So one of our goals, what I would like to do in this talk is to help sort of give you a framework for thinking about these issues, the scope of the problems, and some approaches about how to sort of think about solving them. We're going to start by talking at a high level about what are some of the problems that you'll encounter, then move on to think about testing in three buckets. So and sort of how to think about those, and then finally a proposed approach for how to build this into your own company. So types of problems. The reference architecture that I want to use is pretty simple. It's a sort of a simplified version of a pipeline. You have one data source, Postgres. It's your OLTP application data that gets synced into Redshift. Various tables from your Postgres database get synced into Redshift via S3. On Redshift, you're running a bunch of queries, and then it's being served out to Elasticsearch for reporting purposes, or your data scientists have access to Redshift tables as well. This is being orchestrated by a single system, Apache Airflow. For those who aren't familiar, Apache Airflow is just a workflow scheduling tool that implements a graph of dependencies against your jobs. So to dive a little bit deeper, some of the individual components of this pipeline is to move data from Postgres to Redshift. You're selecting from Postgres and you're moving it into S3. You want to do change data capture here. You don't want to, you only want to move data that's changed since the last time. So you have to keep a page somewhere, probably in S3 or even in Redshift, to determine, what was the last point that you copied from. And then you're going to copy that data from S3 into Redshift. Once the data is in Redshift, you will run thousands of queries on it, hundreds maybe, to join it, aggregate it, move it around, and then put it into a state where it can be normalized, potentially implement some sort of classic OLAP cube or other data warehouse design methodology so that your analysts and data scientists can really understand what it looks like. And then finally, you'll move it out to Elasticsearch. So, some of the Redshift tables you'll move into Elasticsearch for serving into an analytical application. One of the main reasons why you want to do this is because Redshift is not a low latency database, and so if you're going to run an analytical application, you'll want to move some of the data into a database that's optimized for reads. So you'll then move some of the Redshift data out into a different database, Elasticsearch. So what can go wrong? A lot of things can go wrong. Some of the high-level things that we see go wrong most often is that there's logical errors in the code that you have to move data from one system to the other, where you end up missing rows or you have duplicate rows. This can be caused by operational problems, like your ETL pipeline doesn't do a good job of recovering when there's a failure, or there's logical issues in how you insert data into Redshift where you're improperly determining the uniqueness of a row, and you end up getting duplicate rows. That's obviously problematic. You can have logical errors in your joins and transforms. If your transformation logic is implemented as very long SQL, individual long SQL texts, you'll end up it'll be really hard to do unit testing on that. And so sometimes when you're joining tables together, if you're doing complex inner or outer joins, you might end up getting more rows or fewer rows than you expected, and you won't really realize that until later. And then you also have physical errors of your actual job runs, where queries are slow, or they're being killed, or they're being aborted, and your pipeline logic might not handle those issues well, and one stage of the pipeline might run but expect data to be there and improperly handle missing data. So you'll end up having the wrong, incomplete data in your destination tables. So these are sort of classes of issues that we'll discuss. Now, in terms of the types of tests that you should be running and thinking about running them, we think about tests in three categories. Oh, by the way, forgot to mention, I'll do a Q&A at the end of the presentation. So drop questions into the Zoom Q&A widget, and after I'm done, I'll go through those and answer any questions that were asked. So the types of tests. So on the front end, you've got just your pipeline health. This is sort of the physical infrastructure that runs the jobs. Are they running? Is the latency of your DAGs and task consistent? Then moving on to the data itself. So I sort of bucket these into things that should work, and then then the unknown unknown. So the data validation side is, you've got queries that you're running, and you should be able to determine and write a test to determine you have an expectation of what should be there. And so if you're joining two tables together, are you capturing all the rows? Those are things that you can be pretty deterministic about because you've written the logic yourself. And then finally, there's like the unknown unknowns, right? If you start receiving data in a different format, or you start receiving different types of data than you expected, or there's some other logical error in your transformation, is anomaly detection, right? Is trying to find those things that you might not be able to determine exactly what the problem is, but being alerted to an anomaly will oftentimes lead to a bug and point you in the right direction. And so some examples of pipeline health tests, but going back to that first topic, are my tables up to date, right? If I have a sort key in a table and I expect it to be updated every hour, is that happening, right? And if it's not happening, I should be alerted by that. Is the average latency of all the queries of the queries that I'm running for a particular transformation, is the average latency of those queries changing over time? If the average latency of a query is going up over time, or a group of queries is going up, eventually that will cause the subsequent steps in my pipeline to fail, or to slow everything down. So I sort of need to know right away if that's happening and why it's happening. Are there contention issues between how I'm running queries that are creating table locking issues or other problems with scaling that workload that might impact query latency? Is the entire DAC finishing as expected, right? Or is it finishing in the time period that I expect? And then finally, resource monitoring. Or if queries are failing, are they being aborted? Why are they being aborted? Is that due to, are they timing out, or are they being aborted by some other system? Is my application aborting them due to a timeout? And then resource monitoring of the underlying system itself. If you're talking about Redshift, where storage and CPU are tied to the same node, you really want to keep an eye on your storage utilization, because if you exceed a certain level, you'll start having a lot of issues. And so monitoring that's really important. Some examples of data validation. So some pretty simple things that we can just do across most of the queries that we run is to, as we're syncing database tables from one SQL-based database to another, or from one table to another, is to simply do counts of rows in the source versus the destination over a fixed period of time. This will help you to identify missing rows or duplicate rows. That's sort of really important test that you need to have. For transformations, if you're doing a join across two tables on a key, then measuring the count of distinct unique primary keys in the source table versus the destination table is a test that you could do to make to make sure that those numbers are the same, because they should be if you're joining on that key. There's a lot of column levels within a table itself. You can look at statistics for individual columns as well. And we'll get to that a little bit deeper a little bit later. And then you also want to add into your pipeline really, really good type checking, because as we discussed earlier, third parties sometimes are loading data into your database. And so most issues that we see with data pipelines is when we have a mismatch in type when inserting a row into a table that causes the pipeline to fail. And if you don't see that early on, then and you allow that to actually go through, it'll have ramifications for your pipeline down the road. So anomaly detection is probably one of the most interesting areas. There's a number of things that we can do here. To let us to point to issues that might be problems. Looking at over time, the number of new rows being added to a table, right, is something that should not change too drastically if everything is equal on the data source side. Table growth by size, this obviously should take pruning into account if you're pruning the table. Looking at various statistics on columns, and even further than that, trying to stratify the values within within a particular column, and some more advanced anomaly detection that we can do as well. We're not going to talk about that too much here, but we'll talk about a framework whereby you can have access to that data. So talking about how to actually put all this together, I wanted to propose an approach for how to develop and run a test like this in your environment. So what are our goals, right? Our goals are to be able to easily support new data and components, right, as they in all different formats as they're added to our system. So we don't want to build anything that makes any assumptions about the structure of the data or the type of the data. Like we said earlier, separation of concerns I think is critical. We want to separate the ETL efforts, changes to pipelines, how pipelines are shifting. We want to sort of separate our testing framework from that, right? Like we don't want to have to modify our ETL pipeline to add a new test. That would make it hard for us to add new tests, which is not the goal of this. So for example, what we don't want to do is add the accumulation of test metrics into our ETL jobs themselves, because that would mean that adding additional test metrics or metrics that we would validate for a test would have to, would require adding a new step in our ETL process. We want to be able to get alerted quickly if there's issues. So we want, hourly granularity ideally, not daily, not weekly. And then to from an operations perspective, a failure in your pipeline should not cause a failure in your testing framework, and vice versa. For maybe obvious reasons, if your ETL pipeline fails and it's also responsible for monitoring itself, you won't know about that because your monitoring system is down. So what if we had just a simple daemon, right, that would just crawl your database, your S3 data lake, and it would just not have any knowledge of the overlying infrastructure or the ETL infrastructure that you're using to write queries, but it just only looked at your table relations. And all it did is it went out and it gathered statistics on all the tables that you have. So Redshift tables in S3, if you're storing data in Parquet or ORC format, or even JSON, or in a format like that, you can leverage the Hive metastore to enumerate the various table relations and sort of use that as a way to gather statistics on various partitions within S3. And then for each table, just generate as many metrics as you can, and stuff those into a metrics database. This can be a MySQL database. It could be something more advanced. But really here, you're just storing numbers. So it should be super, super fast and cheap to store. And then you can visualize them. So I want you to think about this as a framework for solving this problem, where we would separate the complexity of our DAGs and our tasks and our pipeline from the actual database tables themselves, and elevate those as the first-class citizens that we're evaluating. So what are some examples of statistics that we would look at? So for a numeric column, calculate the min, the max, the average, the square root, the amount of rows that are null, or the percentage of values that are null in this column, right? If this is information that would be very valuable to do anomaly detection on, or to do other validation on, right? If you have a numeric column and you're storing age, human person's age, and you get a value of 200 or 1,000, it's probably a problem there, right? For string columns, you can do a lot of things too. You can look at the length of your strings. You can count the number of distinct strings. Again, null count should be done everywhere. The width, the width of a column is important for you to measure. If you're even if you have a var char 4000 table, but you're storing like email addresses in there, if you get something that's like 3,000 characters long, you kind of want to go check out what that is, right? Is that a valid, is that a real email address, or like what's going on there? And then for the tables themselves, if you can determine the sort key, which is a schema statistic, you can sort of measure what is the last updated time of this table for every table run. Measure the number of rows in that table at the time that I was querying it, and the size of the table. So in that way, depending on the interval that I'm testing, I can get a picture of what is the growth of rows and size of that table, and what is the recency of that table. And typically, not all tables have timestamps or sort keys, but this will allow you to plot the delta between the runtime and the recency time for that run, and set up alerts if the recency of a table exceeds a certain threshold, like hour or 3 hours, whatever your business decides. And so what are some examples, right? So say we wanted to compare rows. In our reference architecture, we were talking about Postgres and Redshift. Well, if I wanted to compare rows between those two databases, I sort of have that data already, right? I've enumerated all the tables in Postgres, all the tables in Redshift. I've calculated these statistics on them. So I sort of have that data. It's just a matter of writing a test for me to compare it over a certain time range. Table recency is a test of the difference between the time that the test ran and the last updated time of the table in question. And so if I were to store these data in a table, I could set up an alert when that value exceeded a certain threshold. So for each table. So I could just have a time series of recency for all my tables. I could even plot that, and I could sort of, measure what is the average recency of a table within my pipeline. And then if that starts, even if that starts going up, even if it's still within my threshold, if it starts increasing, if that delta starts increasing, it's a harbinger of an issue. If you're properly measuring your query latency or your DAG latency, those two things should also correlate, right? Your recency of a table is tightly correlated to the runtime of the jobs themselves. So in that case, you would see both of those things happening. If you want to validate joins, and you want to do that by comparing a distinct count between the values of the pre and post join column within the source and destination table, you have that data too, right? Because you've calculated the distinct a distinct on all the columns in your tables, and if your test knows what are the primary key or keys within each of those tables, the number of distinct keys should be the same for a particular test run across those two tables. There might be off by 1 or 2 for various reasons, timing issues or whatever, but it should never be off by 50%, right? So, looking at the anomaly, so on the anomaly detection side, this is more a matter of, okay, now that we have the data, right? We have rows, we have gigabytes, we have various statistics on our numeric and on our textual columns. The challenge you'll have here is classifying the behavior of the current system to reduce noise. No system is perfect. You'll have 1 or 2% of issues across any of these systems or variants. But if you're able to effectively acquire this data and run it through an algorithm that will help you classify and detect anomalies over time, maybe we're not looking at anomalies over the past day. Maybe we're looking at, a 2-week rolling average of a metric compared to, or like anomalies over a 1-week rolling average, or like only alerting if we're 2 standard deviations away from the mean on a particular metric. That's still really, really valuable, because it's really hard to detect when something goes from 1,000 to 10 unless you're doing something like this, right? It's easy to say something went to 0, right? Because like my job failed. But if the number of rows per hour is typically between 10,000 and 20,000, but it's been at 5,000 for the past day, maybe that's not a problem, but maybe it is, right? And so if you're storing all these statistics, you can see how it would be pretty straightforward just to sort of run all of that through algorithms to sort of help you figure out or help to elevate what's wrong. So that's the end of the presentation. I wanted to ask and invite you to email me if you have any feedback or any questions, or to join our beta program. Intermix is building out functionality like this. We have some of it already within our own product. We're looking and recruiting companies and individuals that are interested in working with us to talk. I'd love to talk to you about some of the challenges you have in your environment with data validation and anomaly detection, and share how you've solved those problems today. And I'll share with you what we're planning on working on. And if you're interested in working with us, we would love to sort of share some software for free as an alpha user early on and get feedback from you. So let's go into Q&A. We have a little bit of time here. So Lars asked, what are some of the data pipeline products you see companies use? So great question. So I'll answer that in 2 categories. One is the workflow tools that we're seeing, and then ETL as a service tools to actually move data around. For workflow, for actually just running jobs in your infrastructure, we see a lot of Apache Airflow, which is an Apache project that just it's a job scheduler. We'll also see Luigi, which came out of Spotify, and then Pinball, which came out of Pinterest. although Airflow has captured most of the, I think is the most active project. Most companies use it. ETL as a service is pretty big. We see, look, if you're going to synchronize data from an OLTP database into Redshift or another database, you probably want to use a third party. It's hard to do it. It's hard to do it well. We see Fivetran, we see Stitch data is great. Illuma, ETL Leap. There's probably 50 of these companies out there right now. So Bill asked, what is your view on frequency of data signature generation versus performance needed to calculate? That's versus performance. That's a great question. That's a really good question, Bill. Everything, measuring anything causes a load on that thing, right? So if we're going to calculate statistics for tables, it's going to impact our database. I found that half an hour is reasonable in our experience. If we poll these metrics every 30 minutes, we'll get pretty good granularity. And if you can wrap up your statistics gathering into a single SQL query, then it really just looks like a single table scan, which on an OLAP database is pretty efficient. You can also reduce that performance hit by doing ignoring columns that you don't care about. Sometimes we have thousands of columns just because we're using segment or something similar. And then there's just one column for every attribute in my data model. I don't care about 95% of those, so I don't need to scan those at all. It's a great question, Bill. So Kevin asked, for companies that you've worked with, what does a successful team typically look like? For example, the ratio of data engineers versus analysts. So that's a great question, Kevin. We see much more analysts, very small data engineering teams and very big analyst teams, like 3 to 100, like ratios like that. And I think with automation, you can get away with having a pretty big infrastructure pipeline with like 3 or 4 data engineers. And what you'll be doing there is spending most of your time writing ETL pipelines, writing data sort of setting up data validation tests, acquiring new data, figuring out really how to model your data in a way where it's going to be performant, and then also figuring out what's the best database for my job. But we have customers that have 3 or 4 data engineers, and sometimes they've got 1,000 users running on a business intelligence tool or reporting tool like Mode or Looker or Chartio. So there's a pretty big gap there. So Monik asked, I'm using, sorry, I was reading Monik's question. So we're using AWS data pipeline to ingest data from S3 to Redshift. And I'd like to understand what are the recommended ways to do reconciliation. I mean, how can we report on the number of files landed by the table and the files ingested? So AWS data pipeline will still use S3 as the staging area before it gets copied into Redshift. And so one of the things that you can do here, and I think your question is, how do I actually make sure that the data pipeline is working correctly, and like how do I validate that the files ingested are or the number of rows ingested in Redshift is correct. If you're using a tool like data pipeline, you can bet you can bet that Amazon has tested that for you and that they're pretty confident in that. But one thing that you could do is just count the number of rows in the S3 files versus the Redshift table. I'm not sure exactly what your architecture is like, but one thing that we do is we'll use Python in the Bodo library to scan the S3 paths and just do a count of the number of rows in there, and then compare that to the number of rows in the database tables. So that'll give us a test between like validation between S3 and Redshift. But I'm not sure if that answered your question, Monik. But please email me after this, and then we can have a deeper discussion about that. Oops, sorry, my. So Kevin asked, any publications, blog, video channels you follow to stay up to date on new tools? You should subscribe to SF Data weekly newsletter. We'll send it to you after this, and it's something that we curate weekly, and it just has a list of cool new projects, new tools, new approaches, popular blog posts for data engineers. Also, take a look at the Data Eng Conf. It's a conference for data engineers, and they're doing them now probably 3 or 4 times a year. The next one is in New York and Barcelona, but they have some great resources on their YouTube channel and their website as well. Kevin asked, any cool new projects you know about that would benefit data engineers significantly? I mentioned Airflow is a great project. Take a look at Data Build Tool, DBT. Well, obviously Intermix. You guys should definitely look at Intermix because we build projects for data engineers, or our company is focused towards data engineers, and so we want to make your life better. So take a look at our product. Take a look at Data Build Tool, DBT. Data Build Tool is a set of APIs and libraries for Python that allows you to write once, run anywhere SQL. So if you're creating tables, like SQL tables, you can just write that once using their interface, and then you can run across any SQL database. So you don't have to modify your SQL to support the difference in dialects across various SQL engines, and then they give you a bunch of cool like automation as well to help you with that. So another question, Julian asked, is your software going to focus on data analysis and visualization, or more on monitoring the data generation and processing? It's the first contact for the company. So yeah, thanks for asking that, Julian. Our company is a monitoring company, and we focus on giving you tools, a single dashboard to help you keep an eye on your critical data flows. So if you're using multiple databases, you have complex DAGs and tasks, our tool gives you a view into sort of figuring out problems, monitoring the experience of your analysts and your data scientists and your DAGs to be sure that you're the first to know when there's issues and that you can be confident that your pipelines are working. So it's a monitoring system. We integrate with visualization tools like Looker and Mode and Periscope data. So with our tool, you can see into your Airflow jobs and into your Periscope, Mode, and Looker dashboards to isolate, to sort of look at the performance of what those queries are. And if you have bottlenecks in Redshift, for example, if you're using Looker and everyone's running Looker dashboards and queries at the same time, our tool can help you sort of figure out which users are contributing to those spikes in utilization, which dashboards are the ones that are causing those bottlenecks for you, and then help you tune your workload manager as well. Great. So I think that's the end of the questions. And we will send out this a link to this deck as well, so you have it. And again, please please feel free to email me. We'd love to hear from you. And thanks for joining. We'll talk to you next time.